All right, here's our second video in 4.2b talking about scientific notation. And you might be wondering why we're talking about scientific notation in this chapter with exponents. Well, you can see in scientific notation that we have 10 raised to a certain exponent. And when we're taking these scientific notation numbers, really, really big numbers or really, really small numbers written in scientific notation, we can perform certain operations with them, multiplying and dividing, we're going to talk about right now. Or we can do that more easily in scientific notation by taking the common terms, like terms, and multiplying or dividing them, and then taking the like bases and combining them together, but using our exponent rules. Let me show you what I mean. In example number 8, if I ask you to take 1.8 times 10 to the 9th power, a really big number, and multiply it by 2.3 times 10 to the negative 4 power, a really small number, how can we do that without actually using those really big and really small numbers? Well, my 1.8 and my 2.3 are like terms. They're just regular numbers. We should be able to take that 1.8 and the 2.3 and multiply them together. You end up getting 4.14, which is perfect because remember the rule for scientific notation says that we have to have one non-zero number in front of that decimal. So that's perfect. But then we can take our tens because they have the same base and we can put them together. We can multiply our 10 to the 9th times 10 to the 4th by, remember, smushing the bases together. And do you remember the rule when we multiply, what do we do with the exponents? Yeah, we really add them together, right? So I can take those like bases, I can combine them, and I can really say that I have 10 to the 5th. So we can combine our like terms a little more easily by taking the 1.8, multiplying it by the 2.3, my regular numbers, and then taking my base 10s and combining them by adding the exponents using my exponent rules. And so my new number in scientific notation would be 4.14 times 10 to the 5th. A little bit easier than using the really big and the really small numbers in our calculator. All right, look at B. This is a division problem. I have 3.41 times 10 to the 5th, a really big number, divided by 1.1 times 10 to the negative 3, a really small number. You can write it the way it is, or isn't this division sign the same as a division bar? And so if I have this division problem, 3.14 times 10 to the 5th divided by 1.1 times 10 to the negative 3rd, I should be able to divide like terms. Because we're just multiplying here, we just have things that are factors of. And so we should be able to reduce or divide like terms. So I should be able to take this 3.41 and divide it by 1.1. So in my calculator, 3.41 divided by 1.1, I ended up getting 3.1, did you? Which is, again, perfect because we want one non-zero number in front of that decimal. Then I should be able to take my like bases here, my tens, and I should be able to combine them as long as my bases are the same. Do you remember the rule we use when we divide things with exponents? Remember when we divide, we actually subtract? So really on this one, I should be doing 5 minus a negative 3. And those two negatives make a positive. Or if you think about taking this 10 to the negative 3 and bringing it up, doesn't it become positive? And so then I have 10 to the 5th and 10 to the 3rd, which really gives me 10 to the 8th power. So my final answer, after dividing these two numbers that are in scientific notation, is a new scientific notation number of 3.1 times 10 to the 8th. Just kind of using our exponent rules. Let's look at a few more. These ones are a little bit different, so be careful. Just like we did in the last example, let's take these two scientific notation numbers and let's multiply them together by multiplying their like terms. So let's take the 3.1 and multiply it by the 4.5. I got 13.95, did you? And then let's take our tens, our base 10, 10 to the 5th, times 10 to the negative 3rd. We can combine them, remember, by adding their exponents, and I got 10 to the 2nd power. Now be careful, this is not our final answer. If we are given our problem in scientific notation, then our answer really should be in scientific notation. And technically, our answer right now is not in scientific notation. Well, how come? Well, remember, there's only supposed to be one non-zero number in front of that decimal. And right now, we have 2. And so we've got to work with our problem a little bit more to make it into scientific notation. We've got to move that decimal place over one more time. So I've got to take this 13.95 and I actually have to change it to 1.395. Well, I changed it by taking it and moving my decimal place over. So this 1.395 times 10, right, if I were making it bigger, multiplying it by 10, would turn into 13.95. So that's what I did. I took the 13.95, I moved my decimal place over 1, and so I converted it into scientific notation. But don't forget, we still have this 10 to the second power from our original answer. So really, how many 10s do we have? Well, it looks like we have 10 to the first and 10 to the second. So really, our final answer is 1.395 times 10 to the third. That final answer is in scientific notation. So now we're done. All right, let's do the same thing for B. B is another division problem where we're taking a scientific notation number and dividing it by another scientific notation number, which means we should be able to divide like terms. We should be able to take the 7.2 and divide it by 8. We should be able to take the 10 to the negative 7th and divide it by 10 to the 6th, right? We should be able to put our like terms together. All right, 7.2 divided by 8. I don't know about you, on my calculator, I got 0.9 or 0.9. When I divide, I really subtract the exponent, so that's a negative 7 minus 6, right? Which is really 10 to the negative 13th, so be careful with that one. Remember, it's negative 7 minus 6, so negative 13. Now be careful, this is not in scientific notation. Even though it looks like it almost is, it is not quite in scientific notation yet, because remember the rule is we have to have one non-zero number in front of that decimal. And right now there is a 0 in front of the decimal. So what we have to do is we have to move this decimal back one time, right? And so the 0.9 to me is a small number. It's a number smaller than 1. And so I'm going to take that 0.9, I'm going to move my decimal behind it, which makes it a 9, and then I'm going to say that I'm multiplying it by a negative 1 power. 10 to the negative 1 power, really. So 9 times 10 to the negative 1 would really mean I'm taking this 9 and I'm making it smaller by dividing it by 10 once, which is 0.9. That's how I kind of converted it back and forth. So I have 9 times 10 to the negative 1. I still, though, have the 10 to the negative 13th from my previous answer. And so really, how many base 10s do I have? Well, I have 9 times 10 to the negative 14. I have one non-zero number in front of my decimal, and so my final answer is now in scientific notation. Kind of tricky. Why don't you try these few before you move on and try your homework? So some try it problems. I'd like you to pause the video. I would like you to try these 3 and then come back and see if you got the same answer as me. All right, and try it number 1. We have this quantity. The whole quantity is raised to the 0 power. Remember, there's a rule. Anything to the 0 power is 1. As easy as that. All right, look at number 2. I have coefficients here. 9 doesn't go into 12 evenly, but I can reduce. What number goes evenly into 12 and 9? It looks like 3 does, right? And so we can reduce that. You should also be able to put together your like bases. So your x's should be able to be combined, and your y's should be able to be combined. And so I reduce my coefficients, my 12 over 9 to 4/3. I subtracted my exponents when I divided, or I reduced x's from the bottom and x's from the top, y's from the bottom and y's from the top. I ended up getting a 4x cubed on the top and a 3y squared on the bottom. Or you can say 4/3 times x cubed over y squared. All right, the last one is our scientific notation where it looks like we are multiplying these. So you should be able to multiply your like terms. 3.1 times 2.1 is 6.51. And then I should be able to take my like bases, my 10 to the 7th times 10 to the 4th. And when we multiply, we really add the exponents. And so I ended up getting 10 to the 3rd. Now, is there one number in front of our decimal? One non-zero number in front of our decimal? It looks like it. So it looks like we're in scientific notation, and that's our final answer. Hopefully you got the same answers that I did. Let me know if you have any questions on this section. Make sure you're practicing your homework and let me know if you need anything.